During this session, what I'm going to do is take you through a basic chemistry beginners class. We need to get some ideas about the structure of the nucleus steady, so then we can start thinking about some of the ideas of radioactivity later on in this course. So if you've been exposed to any chemistry at all, this should be fairly straightforward. Now, I hope everyone is aware that all the elements we see around us can be organized into what something is known as the periodic table. And the periodic table shows all the elements we discovered and then a very specific order. The order reflects both the number of protons they have and also the location is dedicated to the number of electrons they'd normally find in their outer shell. So we're just going to think about the nucleus here and how it's organized and why each of these elements are in these different locations. So every element has what's known as an atomic mass and an atomic number. For instance, we have helium here. Helium has a mass number, which is the number of protons and the number of neutrons found in the nucleus. So the number of nucleons in total, and that's the mass number. Here we've got the symbol. This is the symbol for helium. And then I have the proton number, and this is just the number of protons. Now it's important to recognize that the mass number and the proton number are related to each other. Okay? And what we can do is, by looking at the relationship, we can work out some other things. What we can find out is that if the mass number, or the nuclear number, which is often given the letter A, and the proton number, or the atomic number, which is often given the letter Z, when we think about these two things, if we think about for gold, for instance, the proton number is 79 and the mass number is 197. By subtracting 197 from 79 from 197, it gives me the number of neutrons, which is 118. So you've just got to remember that the number of neutrons equals the mass number minus the proton number. So that's one little thing that you need to recognize. Now, let's think about this. Here I have three elements all marked with a large C. This C stands for carbon. We know that they're all carbon because they have exactly the same number of protons. That's 6. However, their mass number is different. And this is quite an important feature, because what we have here is that these elements are different because they have different numbers of neutrons. So the same number of protons, but different number of neutrons. Now, an element or an atom which has a different number of neutrons is known as an isotope. So each of these are isotopes of carbon. And as it happens, when we look a bit more detail, we're later on going to think about particularly carbon-14. Because carbon-14, because it has slightly more neutrons, it means it's slightly less stable. And that means it gives off lots of radiation. So it's known as a radioisotope, which is an unstable isotope which gives off radioactivity. And we're going to talk about more about that later on in the unit. Final bit of thinking to do with the nucleus are the forces which keep this nucleus together. For anyone who's done anything on electrostatics, they're going to realize that if I have two protons which are positively charged, they're going to want to get as far away from each other as humanly possible, whilst at the same time the electrons are going to be naturally drawn and attracted towards the protons. So there's a number of forces which we need to think about to keep this structure in place. First of all, we accept that there's Coulomb's attractive forces between the electrons and the protons. But the reasons why they don't collapse on each other is because there's some forces also going on. We have what's known as the weak force. Now the weak force is a near contact force which acts between quarks and leptons. These are the kind of integral parts of protons and neutrons. We don't need to worry about that too much, but it is a driving force for things like beta radiation being released from an atom, and we're going to think about that in more detail later on. There's also the strong force. Now the strong force grips the protons together and therefore overcomes that electrostatic repulsion which is being caused by Coulomb's law taking place. So those are the three forces which hold the nucleus in place. And now you have a general overview of the nucleus and some understanding of the numbers which are used to describe it.